In this video, we're going to move out of the introductory section of the course, and we're going to move toward the section of the course on descriptive statistics. Descriptive statistics. Okay. Now, what do I mean by that? Well, in the first portion of the course, we learned different ways to present data, talking about frequencies, proportions, and percentages. And most often you were looking at a particular variable and you calculate the frequency for a particular value or a particular category of that variable. You might have calculated the proportion and the percentage of the sample that was contained in that particular category. Well, here we're getting away from looking at specific categories, different ways of presenting that data for a variable, and instead what we want to do is we want to describe the distribution of a particular variable. And we can use histograms to help us do this. We can use the concept of a histogram to help us explain what we're doing. So let me take a second here and we'll draw just a theoretical histogram, right? This is a frequency distribution for some variable x, and we've got a histogram here that looks kind of normal. Somewhat normal, not perfectly normal, but somewhat normal. And so we've got this distribution here. And what we want to do is we want to think about different ways that we could characterize the variable as a whole, right? And we want to characterize this variable x for the entire sample and be able to describe it. And we would like to do that in as simple a way as possible. So using the two axes, right? There's a y-axis and an x-axis on this histogram. Using these two axes, we can ask two questions that would help us describe the distribution for the variable x. And so one of the first questions that we could ask is, where do the values of x cluster? Okay, where do values of x cluster? Well, and as a simple example or simple view of the distribution here, we could say very easily, well, they seem to cluster right here. You know, here's this peak. And so there's the greatest frequency of observations are right there. And whatever this value of x is down here, that would seem to be where things are clustered together. And that's a perfectly reasonable way to answer that question. So there are a few different ways that we could actually come up with a value, right? The question is, what is the value of x? We want to know what is that value that represents the point of clustering. And so we could answer this a few different ways. We could answer it by saying, what is the most common value? Okay, so we could take the most common value of x, whatever that happens to be, it's whatever this is here, and that would be one way of measuring the point at which the values cluster. We could also say, we could also answer this question by calculating the value in the middle. In the middle of the distribution. So we've got all of these points. We can imagine we're lining up our points. Each observation in the data has a value of x, and there are more observations in the middle here, and even more in the middle here, and there are fewer out in the tails. But if we had dots for each of these different points in the sample, we could say, okay, find the point that's right in the middle, that's the 50th percentile. And then we could take that value, whatever that value of x is, and we could use that as a measure of where the values cluster. As a third way to do this, we could simply compute an average. And this is a concept that most people are familiar with, but we'll get into more detail on in an upcoming video. But this is also a perfectly reasonable way to characterize where values of x cluster, and we could calculate the average. So the important thing is that what we're doing here is we're looking at this dimension of our data and sort of where do we fall along this x-axis? Where does this peak lie? And so we can think about, as the peak moves from left to right, the point of clustering will move from left to right as well. And so we can treat this dimension of our distribution as one type of descriptive statistic. We're trying to describe where the values cluster, and we would call these types of descriptive statistics measures of central tendency. Okay, measures of central tendency, because they're trying to measure the central point of the distribution. Now, a second way that we might, or second question that we might ask to describe our distribution would be to ask how much do the values of x differ from one another? Okay, so how much do values of x differ? And again, in this, when we ask this question, what we're really talking about is how spread out these values are. And so we can think about this as being the other dimension of our histogram and our distribution here, going from left to right. How wide is this bell curve, or how narrow is this bell curve? The more narrow the bell curve is, the less the values of x will differ from one another. The wider this bell curve is, the more differences there will be in the values of x. And so there are a couple of different ways that we might be able to do this as well. We could calculate the difference between the low and high values of the distribution. So whatever the lowest value of x is down here, whatever the highest value of x is up here, we could calculate the difference between those two, and that would give us some measure of how these values differ from one another. Another way that we might be able to do this is to look at the differences of observations in our data from the average. Okay, so if we let's say that this was our average here in the middle, we could calculate a difference in the average between the average and each data point. And we could figure out what the differences are from average and every other observation in the data set, and then perhaps add those up, and we come up with some value of how different these data are from one another, and how much the values of x differ from one another. And so when we talk about how these values differ, we're talking about this left to right dimension in the data set and in the distribution. And so we can characterize this and call this a descriptive statistic, and in particular it's a measure of dispersion. In particular, we want to know how dispersed the data are for our distribution of x. Okay, so we've got measures of central tendency, and these are used to answer the question, where do values of x cluster together? Okay, and there we're interested at what value do we find this peak, what's the most common value, what's the value in the middle, or what's the average. Over here, answering question number 2, when we ask how much do the values of x differ from one another, we're talking about measures of dispersion. And here we could be talking about the difference between the low and high values. We could be talking about the differences from the average value to every other observation. But what we're really getting at here is how wide is this curve? How wide or more dispersed are the values in the distribution, or if it's a very narrow curve, if this distribution is not very wide and the bell curve is very narrow in the middle here, then we would say there's less dispersion, and we would expect that our measures of dispersion would reflect less variation here. So these are two ways, two questions that we can ask to describe the distribution of a variable x, and that's what we're trying to do in this next section of the course. We're just going to take a variable from a data set, x, and we're going to try and characterize it in terms of the way values cluster together and the way the values differ from one another. And so we'll have specific measures of central tendency to calculate and specific measures of dispersion to calculate.